So thanks everyone to this session. So in this session, I'm going to talk about Analytics Zoo, which is a software platform for big data AI. So let's first look at what big data AI is. So at Intel, we have been focusing on bringing AI to big data, to the big data platform, to big data ecosystem. So we open sourced the BigDL in 2016. It's a distributed deep learning framework. In concept, it's similar to TensorFlow, Caffe, PyTorch, but it's specially built and optimized for Apache Spark, the big data framework, and running on large scale distributed Xeon cluster. So we have quite a few users using BigDL. As we work with those users, it turns out one of their key challenges is really less about which framework, which deep learning framework to use. It's really about how we can build an end-to-end pipeline which brings together many different and separate components like TensorFlow, PyTorch, Spark, Flink, and so on. So that's why we actually open source Analytics Zoo about 2 years ago to provide a unified platform for big data AI with the goal that you can write a end-to-end application to do the data processing and then modeling. And the application can seamlessly scale from a single node from your laptop to a large-scale distributed big data environment.
Hey, Jason.
Yeah, sure.
On one of Fadi's slide, there was a slide that said something about distributed TensorFlow. I noticed the BigDL is distributed solution, but I've never encountered a distributed TensorFlow capability. Does Analytics Zoo support something like that, or?
Yes, BigDL is a kind of a native library for Spark doing distributed deep learning, but it's its own has its own program model and everything.
Right.
And on Analytics Zoo, we bring those TensorFlow, PyTorch, Keras, and so on into the big data platform, so you can run distributed TensorFlow or PyTorch on Spark, for instance.
Okay, I got you. Thanks.
Sure. Also, one of the Fadi's slides, so this next to Analytics Zoo was the Model Zoo. So is it related to this? Are you covering it all, or is it a different concept?
It's a different. Model Zoo is really a collection of models that, new network models that are optimized on Intel platform. So it's a collection of models. Analytics Zoo is a very, actually I won't go into details, but it's a really several layers inside Analytics Zoo allows users to actually build the end-to-end data processing, feature engineering, modeling applications on big data platform. Yeah, it's different.
Okay, thanks.
Sure. As I talked, and we want to provide Analytics Zoo as a platform for big data AI. We think this is actually an important trend or transformation in the industry for two reasons. First, we look at the transformation of big data. When people first started the development of big data, for instance, Apache Hadoop project open source in 2007, the real challenge, the first challenge people want to deal with is really how I can store and process a huge amount of data. So a lot of the focus is really on how I scale my system, scale my architecture with HDFS, MapReduce, and so on, so that I can store those data and I can process it. After that, after we can actually store those data, the next question is how I can actually analyze those data. In those cases, it's mostly with SQL query. So at that time, there were a lot of SQL engines from Hive to Impara to Spark SQL and so on. How different SQL engines you can allow users to query those huge amounts of data. And then people, when people can query those, then another question is that really how I can do do it in real time in both low latency, such as interactive queries, or streaming type of processing. I want to do very low latency real-time analysis. And then today, a lot of focus is really on how I can build some models and predict on the huge amount of data I have. So a lot of focus is really on machine learning and deep learning and AI, of course, how I can actually apply my AI technology and AI models to my production data. That actually is consistent with another trend that AI is actually moving everywhere. When people first start with AI, it's more of a research in the lab environment. You have your standard data sets such as ImageNet, and the people are building various models and try to, analyze those images. And but today, AI is moving from those experimentations to production. It's more than people may say it's auto drive and everything, but it's actually far more than that. Today, we see people using AI when they try to sell hamburgers, when they try to manage their base stations, when they try to manage their wind power farms, and so on. So as you move AI into production, there's actually increasing demand to apply AI to your production data, which is usually large-scale distributed big data set. So those two trends actually drive to the point that big data AI, we see that is critical in that how you can actually apply AI to applications, to everyone's applications, and to improve its efficiency and so on. So let's start with an example. I actually use a case example from JD.com, which is actually one of the largest online shopping websites in China, actually in the world. So in JD.com, they actually try to do one thing. It's pretty simple. They try to do image feature extraction. What does that mean? So you have an image. There is a bird in that image. And then you try to recognize what is the object in the image, in this case, the bird. And then you get that object, and then you transform that object into a bunch of vectors, which is essentially the feature of that object. It's actually is a very common service inside JD.com. It's used in many different applications. For instance, you can take a photo of something, and then you upload it, and it can search using that image what are the items available on their shopping website. So it's essentially a similar image search. Or alternatively, they have a lot of shops on their website, and it turned out it had a lot duplicated. So they try to do image deduplication so that they can be more efficient on their storage, and so on and so forth.
So I'm just trying to understand how distributing the image object detection, image recognition training activity works in like a big data Hadoop kind of massive cluster of servers environment. I understand how the inferencing, and this is kind of an inferencing solution here, would work within that sort of solution, but I don't understand how the training would work.
Yes. To answer your question, in this case, I'm showing a inference solution, an inference pipeline here. I do have examples of how people doing training in latest sections, but yes, this is a inference solution.
All right,
yes.
Gotcha. Thanks.
But even with this simple problem, right? As you mentioned, first of all, object detection is kind of from a research point of view, it's really a solved problem. Right? There's a lot of ways you can do object detection, and the inferencing is relatively straightforward compared to training. But even in this relatively simple problem, when you look at how you apply it in the production environment at JD.com, they have hundreds of millions of images, and so in production, they have to store those hundreds of millions of images in a distributed, big data environment like HBase. And then, to process those 100 million images, they have to do image pre-processing in parallel over all those images, and then you apply those deep learning inference, and then you do another round of pre-processing, and then you get extracted features that start back to your distributed file system. So the way they did it previously, of course, it's pretty conventional. Right? You use some GPU servers to train the model, and then you use a cluster of GPU servers to try to read the data from your distributed file system in parallel, and you apply the inference on the GPU, and they start back to the HDFS and so on. Actually, it turns out there is a lot of overhead, I mean, in both the performance overhead as well as the development and the deployment overhead when you try to essentially manually connect those different components together. So that's actually, when we worked with JD.com, they actually moved their entire pipeline onto Spark using BigDL at that time. So they use Spark to read the data from HBase in parallel, actually at massive scale, pre-process the image, and then use BigDL to do the distributed inference in this case. And actually, as it turned out, the end-to-end performance of the entire pipeline, from data ingestion to pre-processing to model inference and so on, there is actually about 4x speed up when you move the entire workflow onto one unified architecture. In this case, they are using BigDL on Spark, which gives them huge speed up. And it's also much easier for them to develop the code because now they just only use one program model, and they can run it on one unified system or architecture. That's actually one of the key motivation we have. Right? When we see users try to apply their AI models, in this case, of course, it's inference, but we do also have examples of training in later pages onto their production data, which is usually large-scale distributed big data environment. It's actually, there are a lot of challenges, and that's why we want to provide a analytics view as a unified platform for people to do that.
So were the improvements made because they moved to Apache Spark? And then if the answer to that is yes, is the reason they were able to move to Apache Spark is because you had this platform that made it easier for them to get there?
Yeah, I mean, previously they have to do it manually, right? They have to write a code on a GPU server to read the data, and then partition the data, and then they feed that into a model running on that GPU, and then they get a result, and then they need to write it back to HDFS. Every step you need to be manually kind of connected together. And what we're trying to doing here is that we provide a kind of a end-to-end pipeline support, so that every components are already seamlessly integrated, I would say. And so you have a bunch of in-memory data partition across a cluster, and you have those data directly go into your model without all those the connection, the conversion, and everything. And that's one. And then secondly, you can seamlessly scale that out using Spark and so on.
So is Spark? This is going to expose my ignorance. So is Spark is Analytics Zoo on? Is it a Spark provider with all the pieces plugged in automatically to make it easier?
Yeah,
probably wrong word, but
maybe that's a good place to start with this overview of Analytics Zoo, right? Okay. Analytics Zoo actually try to bring those different components together. So it itself does not provide a Spark distribution or a Hadoop distribution. I mean, we have people running it on many different platforms. Some are running on Cloudera, some are running on AWS EMR, some are running actually on Ali Cloud, for instance. So what Analytics does is actually it's try to bring together those different components, including deep learning frameworks, TensorFlow, PyTorch, BigDL, OpenVINO, all those Python libraries, NumPy, Pandas, and also large-scale distributed data analytics systems like Spark, Flink, Array, and so on. So it's actually built. We see that as a low-level components or library frameworks were built on top of it. So with all those different, in real world, when people try to build an end-to-end application, what they really need to do is really just like that. If they take those different components, maybe I use TensorFlow, I need to process the data in Spark, and then I need to do TensorFlow and so on. They manually put them together, and there are a lot of overhead in between. What Analytics analytic zoo does is it tries to provide the end-to-end pipeline, which allows the user to directly run, for instance, a TensorFlow model on a Spark cluster, and can seamlessly scale that across the cluster for both distributed training and inference. So yeah, this page gives a quick overview of analytics zoo, actually more of a concept level. Right? It tried, as I mentioned, it's built on top of those different libraries and frameworks to provide end-to-end pipeline to scale those AI models to the distributed big data environment. On top of that, we also build various high-level machine learning workflow support, such as AutoML, to automate some of those tasks. And on top of it, there is different models people can run on top of it. And well, it's powered by one API, so we are leveraging one API so that it can seamlessly run across different computer architectures in future. So before I dive deep on what analytics zoo, the technical details of analytics zoo, I would first provide a high-level overview of what are the goal, what are the objective we want to achieve with analytics zoo. Really, the goal is really help users to seamlessly scale their AI applications, their end-to-end big data and AI pipeline from a single laptop to a distributed big data. So if you think about a typical life cycle of a data science project, people usually start with their laptop. You have some sample data on your laptop, and you build some prototype, for instance, some Jupyter notebook, and you play with the data. Once you're happy with the prototype, you probably want to experiment it on your history data, maybe last 3 months of data, last 1 year's data. So data in many times could be pretty large, and also start on your production big data cluster, and you will try to experiment on your cluster environment. And when you're happy with the experiments, you will then want to productionize it, deploy it, either in production or maybe A/B testing, which in that case you need to really connect that to your production data pipeline. And today, moving from laptop to cluster to a production environment is really a challenging process. It involves code rewriting, data movement, model conversion, everything. It's a lot of work. And what we try to accomplish with Analytics Zoo is really we allow the user to directly build their end-to-end pipeline on their laptop, which can already apply their AI to their big data, and there is almost no code change. Maybe just one line of code change. You can move from your laptop to a distributed class environment. Yes.
So I mean, something like this you could potentially do with CUDA specifically from a model perspective. But as you go up this scale, you end up having to deploy additional tools, Kubernetes or other solutions to try to scale that model and inferencing and that sort of stuff. I mean, where does big data, where does your solution fit into that framework? I mean, and you could do all this with CUDA, right, without changing one line of the model.
I can give you one, actually maybe 2 examples. For instance, when we have a lot of users who write maybe a TensorFlow model on their laptop, and then they try to run it in a distributed fashion. Well, technically, yes, you can do that, but which actually means you need to change your model in a way that you need to expressly bring those distributed concepts into your model. I mean, for instance, let's say you're using Harold, you need to say expressly managing the data partitioning. So in the data pipeline, you need to check which rank I'm in. So if I'm in rank 1, I do this. If I'm in rank 2, I do that. And then I will expressly broadcast kind of my parameters and everything. And then a lot of time I need to use OR-reduce operators to aggregate those. This is not something a data scientist would like to do. I mean, they don't want to think about the distributed system. So that's one challenge they have, right? When you try to, it's very easy, as you say, I can build a model on my laptop, but if I try to turn it into a distributed version, actually I need to add a lot of those distributed constructs. I mean, Harold is already great in that respect. It actually reduces a lot of those I would say program overhead, but you still the user need to think in a distributed fashion, which is a big challenge for our data scientist users. And another example is how you connect to your big data environment. We have been working with some very large internet companies. They have a very advanced AI researchers. They are building all those AI models in their research environment, very fancy model, more than deep learning. But then after they're doing that, of course, on their laptop, the GPU workstations and everything. And after they build their AI model, the next question is that how I can apply my AI model to my production data. And they figured out that their production data is actually stored in a Hive data warehouse. There's actually no easier way for them to directly apply their AI model to their Hive data warehouse. They have a lot of times they have to copy the data from their Hive data warehouse, sometimes actually between data centers to do that. So that's why they take analytics view, because we can directly apply those PyTorch, I would say, algorithms directly inside their Hive data warehouse. That's actually what,
I got you. Thanks.
Yeah, sure. So that's actually exactly what I mean. We want to have zero code change going from laptop to a distributed environment, and then you can seamlessly deploy on your production environment. That's actually a key when you try when people moving their AI into their production environment. That's actually one of the key challenges we see again and again at many users.
What I'm seeing with many companies is that they think that they have big data when in fact they have very little data. Are you seeing this kind of problems with companies?
I think there are two types of challenges. Of course, some of the companies don't have a lot of data, but I think that's more, it's less a technical challenge. It's more of how you can go into the organization, or maybe go into a business process to collect those data and have it stored and so on. Another challenge is really, a lot of companies have a lot of data, but they don't have labels for those data. And it's challenging. If you don't have labels, it's challenging to build a good deep learning models. And so there is a lot of technology like transfer learning, self-supervision, meta learning, and so on. People are those advanced technology people are applying to try to address that problem.